Hello, this is Andy Huang. I'm going to talk about exploratory data analysis in this lecture. Exploratory data analysis, as known as EDA, is an introductory step analysts need to take in order to preprocess data. It involves methods such as describing the dataset to understand the distribution and handling missing values. We will explore a dataset from Kaggle, housing price information, and perform the exploratory data analysis in Python. The two major topics that we are going to discuss are below. The first thing is data exploration. Reviewing first 5 rows is really important first step. And we will also retrieve information of the dataset. And lastly, we will examine key statistics of the dataset, such as mean, median, minimum value, maximum value, missing values, and etc. Secondly, we will learn how to handle missing value. Are we going to impute the missing value by mean, median, mode, or we can actually reclassify NUR values as n/a character, or maybe others. First thing first, before we actually starting the analysis, we will need necessary libraries. The library we will need for this exercise is pandas, and this is relabeled as PD. So using PD, we then actually retrieved the function called read underscore CSV. And from this, we will actually retrieve the train.csv data file and then put that into variable called df. After loading the information, we will then perform data exploration. First, we will going to review first 5 rows of the dataset. This can be done by .head. So this is like a df.head the method, and then using this function, you will see that the data looks like this. So this is an important step to really understand the data. And from df.info, you can see that how many NUR values are there for each feature. What are the data types for each column? What is the total number of columns? What is the total number of rows? We know that from this df.info, LE is missing almost about, let's say, more than 95% of the values. Only about 91 values out of 1,460 are non-NUR. Similarly, pool QC is missing most of the information. We also use the method called describe. And this method will give you the general data shape of the data frame. For instance, from lot area, you can understand that the median value is around 95K, whereas the maximum value is around 215K. From this, you know that this column is basically highly skewed. From this, you understand the general characteristics of each feature, and you can also decide whether to apply logarithmic function or Box-Cox function to actually normalize the feature in order to approximate Gaussian distribution. But that is beyond the scope, and we are going to talk about in the next lecture. From this information, you now know what to do with the missing values. You can either drop the missing values in case we know that the columns are missing most of the values. In other words, we will just drop the entire columns since the columns are missing most of the values. If the values are not missing most of the values, let's say the general rule you said is like, say, half of the information are there. Well, that's up for discussion, but that's like a very subjective. So you need to really come up with your business logic to really understand how many values are really a lot to you. Impute with a mean value or median value should be based on your personal choice as well. But the general rule is, before replacing with the mean value, we should be aware that the features should not have external values, such as outliers. If you have outliers for numerical columns, it's advisable to use the median approach instead of mean approach. You can also impute with the mode value if the column is categorical. In other words, you're going to impute the NUR value with the most frequent category. Since it's not numerical, you will actually choose the most frequent category as the imputing value. You can also impute with the characters such as n/a or others. For instance, you know that from specific business related region, you know that some houses just simply don't have fireplace. If you have the column called as a fireplace QU, just like we discovered from above, and we know that about 45% of the values are missing, are we going to just simply drop that value because they're missing a lot? The answer might be no, because by business logic, it's just a commonly acceptable that some houses just don't have the fireplace. So fireplace QU means a fireplace quality, but then if some houses don't have the fireplace at all, then the fireplace QU is just simply NUR, and then we will actually impute the NUR value with the letter NA to categorize the missing rows as a distinct column itself. We will going to use the .info method again just to double check to confirm our hypothesis here. We can also use the .set option function to actually set the maximum number of rows we want to retrieve. In general, sometimes you will see that any function that retrieves the information in terms of rows is not performing as intended. It can skip some of the rows that you are going to retrieve because by default you're not allowed to show all the rows. Generally speaking, it's advisable to actually set the number of rows that you want to set up to display all the rows that you want to retrieve. In this case, I set up the maximum number of rows as 1000. And from this isNur function along with the sum function, you can see that how many NUR values are there for each column. So for instance, for ID column, we don't have any NUR values. For LE, we have around 1,369 NUR values. Again, for pure QC, we are missing about 1,453 values out of 1,460. So we confirm that we want to drop these 4 values, 4 features, because they're missing more than 90% of the values. We also set up the rules for imputing with the mode, median, or mean based on the characteristics of the data frame, data type. For garage type, since it's categorical information, we are going to impute with the mode. For lot frontage, for instance, since it's a fairly skewed feature, we're going to use the median for the imputation method. For fireplace queue, again, for the region that I just explained, I'm going to replace the NUR value with the n/a for this exercise. Using this variable, which is called mode 1a, I'm going to put this back to replace the existing rows with NUR inside. So this is simply saying that any feature, any column with the garage type is equal to null. We're going to replace it with the most frequent categorical value from the garage type. For this log frontage, since it's a numeric value, we're going to use the median as an invitation method. And then we are going to drop these 4 values. And lastly, as I mentioned, for fireplace QU, we're going to replace it with the character n/a. And then we just double confirm the result after dropping and imputing the values. We know that some of the values are not imputed or dropped. It is basically my subjective approach here, because we know that these values are not missing so many values. So what are we going to do with this? So given that all the heavy lifting is done, we are going to then just to drop simply the values, the features that are missing some of the values. This is not causing too much problem because these features don't actually, they are not missing tons of values, unlike, let's say, LA. And using this drop NA function, we can actually drop any rows with a NUR entirely. And then we can actually use the isNUR and sum function again just to double confirm that we're not missing any NUR values. So after imputation and dropping the major columns, and also by dropping the NUR values after doing imputation and dropping the major columns, we are left with 1,338 entries out of originally, which was 1,460, which is not bad. So this is basically not a bad approach because, first of all, we took care of that massively missing columns. We dropped them. And then we also imputed the business related information such as a fireplace queue with the necessary characters. And also we handled some of the numerical features and categorical features with the median and mode itself. And then as a final step, we then drop any pertaining NUR rows that doesn't really cost too much since they're not missing too many values. And thank you for watching. And this was my first lecture on data analysis for beginner.